What's up, everybody? Welcome back to another live stream from the Scalar Learning channel. And today we are continuing with our August SAT prep week, day 4 of 5. And as promised, we're hitting digital SAT material today. And that's that. Let's do it. If you guys do like this stuff and like the stuff you see, make sure to hit that like button. We really appreciate it. It does a lot for the channel. If you have any comments or questions you want to throw in the comment section, please do that as well. We'd really appreciate it. And if you haven't done so yet, make sure to subscribe. We got a big video coming out tomorrow at 9 a.m. That's going to be the big dog, so definitely want to be here for that. Let's see here. Sammy Woods, what's up? Prakash, nice to see you. Seven Maduka, what's up? Majid El Mamari, hopefully I'm saying your name right. And Blaster Blade and Dia Star. What's up? Dia Stars. There we go. Anyways, all right. If you guys are new to the channel, the way that we're going to do this, we're going to take this in real time. Usually I say for the first time, but I've taken this test already. So we're kind of redoing it. But remember, the idea is in these streams, try and solve along with me. But the idea is I'm not just doing it, right? I'm actually explaining as I go and teaching you my methods, my thoughts, etc. DSR, yes, I definitely do ACT. We have some good ACT videos on the channel as well. So you can check out the ACT critical concept videos and all that good stuff. Yes, so anyways, that's the idea. Watch, listen, and I'm going to give you different ways to do different problems as well. This is the second module. This one is tougher, and I think historically, if I remember when I took this the first time, I kind of ran out of time on the second module. That's my recollection. So I'm going to make sure to be on time for this one. So that's that. All right. Without further ado, let's do this. If I don't see your questions now while I'm taking the test, because I'm kind of be focused, I'll hit the questions at the end. So anyways, here we go. We're going to start in 3, 2, 1. Let's go. Boom. All right, here we go. There are 35 students in the Spanish club sample of the Spanish club selected at random and asked whether they intended to enroll new. Of those surveyed, 20% responded they intended. Best estimate of total number who intend to roll, so 20% of 55. That's 0.2 times 55, which is 11, but you can do it in the calculator. Boom, done. A machine makes large boxes or small boxes one at a time for a total of 700 minutes each day. It takes the machine 10 minutes to make a large box and 5 minutes to make a small box. Okay. Possible large X. So 10 times the number of large boxes. So 10X. And then small boxes is 5Y equals 700 because we're trying to get the total amount of time, right? So 10 per large box. So 10X, which we have here. And then we got 5Y for a total of 700. So it should be B. This doesn't make it. I don't know what C is. And D, they don't make any sense. But anyways, boom, done. Right? Did I do it right? 10 large, X is large, small is Y. Yeah, boom, done. Okay, number 3. The scatter plot shows a relation between two variables X and Y. The line best is shown. Which of the following equations best? Okay, so we're just trying to get the equation of the line. I see a Y-intercept there at 13.5. And then I see, hold on, let's make this smaller. And then I see a slope of, what is that? Negative, we're going down by going down by 2.5 over by 3. So the slope is negative 5 over 6, approximately. Okay, let's see. Okay, so they have negative 0.8, so that's probably the exact slope. It's probably B. The y-intercept has to be positive, so it's A or B, but the slope is negative. So I didn't even need that much of a calculation. I could have figured it out that way. Boom, done. All right. The point with coordinate D4 lies on shown. What is the value of D? So where is the y value for? It is right here. And that looks like 3.5 for X. Oh, boy. I guess 7 halves. Wait, what? 26 over 7. Oh, that's... No. We need a more precise answer than this. Hold on. I can get the equation because I have the y-intercept and the... Okay. I got 2 points. I got 0, 7, and 8, 0. Subtract down, we get a slope of 7 over negative 8. So negative 7/8 X plus 7. That's the equation of this. And then we need to, when Y is 4, so this will give us the exact answer, plug and chug. And then we solve for X minus 7 from both, minus 7 from both sides, right? Boom. We get negative 3 equals negative 7 over 8X multiplied by 8 over 7 negative. So negative 3 times negative 8 over 7, cancel. That's 24 over 7. So C is the exact winner. Boom, done. All right. For the quadratic function f, table shows 3 values x and the corresponding values f of x. Which equation defines f? Okay, well, let's just see. So when we get -1 for x, we should get 10. Actually, here, this is easy. 0, 14. Oh, they're all going to give me 0, 14. 120. So that's 3, 3, 20. That one works. 5, 6, 20. That one works. 9, 8. That one doesn't work. So C is out. I'm plugging in 1 if you're wondering. 1 plus 5 is 6. Oh, so, okay. C is out. So it's A, B, or D. Ugh. Okay, now I got to plug in -1. This is going to take a while. Hold on. Let me do it here. So -1 squared is 3 plus -3 is 14. So A is out. -1, 5 plus -1 is 4 plus 4 is 18. B is out. -1, 9 plus 1 is 10 plus 14 is 24. That's at C is that's got I guess it's got to be D, right? So it's 1, -5 is -4. Yeah, it's D. So -1 works here, 0 works here, and 1 works here. D is the winner. Boom, done. Plug and chug. All right. Number 6, the function f is defined by this, and f of a is 10, where a is a constant. What is the value of a? So when we plug in a for x, we get a function value of 10. Multiplied by 5, we get 50 equals a plus 15 minus 15. A equals 35. And we got, boom, 35, boom, done. Let me just double check. If f is 10, 50, yeah, 35, boom, done. In the figured lines, m and n are parallel. If x equals this, y equals this, what is the value of z? X equals... Okay, so the relationship between x and y is that they're equal because they are vertical angles, right? So that means I can set them equal to each other and solve for k. 6k plus 13 equals 8k minus 29. And subtract 6k from both sides, we got 2k. Add 29 to both sides, and we got 42. Divide by 2, and we got k equals 21. All right, so k is equal to 21, so now we need a value for z. And by the way, z looks like it's actually supplementary to y because they're same side interior. So if we plug in 21 for k, we can figure out what y is and figure out what's sub to that. So hold on, let me do that here. So we plug in 21. Oh, for either because they're equal. 21, 8 times 21 is 168 minus 29. I could use a calculator, but whatever. 5, 18, 9, 9, 3, 1. So 139. So what's sup to 139 is 41. C is the winner. Boom, done. Wait, let me make sure they were asking for Z, right? You can see Module 2 is already harder than Module 1, right? So the difficulty is going to increase, especially because I think I got everything right on Module 1, so it's adaptive. Line P is defined as this. R is perpendicular. So first, to get the slope, it's opposite reciprocal, but I need to know the slope, so I'm going to isolate y. 2y equals negative 18x plus 9. Divide by 2, y equals negative 9x plus 9 over 2. And so we need the opposite reciprocal, which is positive 1 over 9. C is the winner. Let me just double check I didn't make any mistakes. Negative 9, positive 1/9. Boom, done. Okay, number 9. Wait, that was 8, right? Okay, number 9. A sample of oak has a density of 807 kilograms. 807 kilograms per meter cubed. And the sample is in the shape of a cube, like this, where each edge has a length of 0.9 meters. 0.9 meters. To the nearest whole number, what is the mass? Okay, so if we want to get mass, we can take this density and multiply it by the volume. Because if I multiply by volume, aka meters squared, what's going to happen is the meters cubed, are going to cancel out, and we're going to be left with just the mass. So what is the volume? Since each side is 0.9, it's 0.9 times 0.9 times 0.9, which is, I believe it's 7.729 from my recollection. But let's double check. So 0.9 to the third. Yep, 0.729. So then we got times 0.729 meters cubed. Cancel. So let's do that in Desmos. 807. Hold on. All right, here, it's just that times 807, and we get 588.303. 588 is the answer. Kilograms, boom, done. Okay, the function P models the population in thousands of city years after 2000. According to the model, what the population is predicted to increase n% every 18 months. What is the value of n? Wait, n% every 18 months. Hold on. Years. Okay, so it's 4. So 4% is what it's doing per year because T is years. No, wait. So wait a minute. Hold on. I'm going to have to plug in 1.5 for T. So 1.5 times 4/6 because that's 18 months. 1.5, hold on. 1.5 times 4 over 6. Oh, is it 1? So it's just 4%. It is 4% because 1 year, yeah, because 4/6 are 2/3 times 3/2. Yeah, that cancels out to 1, and that is 18 months. And then you're multiplying it by 1.04, which is a 4% increase. So 4 is the answer. Let me just double check. Yeah, I think that's good. Weird question. Okay, 11, free response. In the given equation, k and n are constants and n is greater than 1. Equation has no solution. All right, so we got a no solution situation. What I'm going to do is I'm going to distribute the 2 first. 2kx minus 2n equals negative 28/15 x minus whatever that is, 36 over 19. But the idea is, if this is going to have no solution, these two coefficients need to be equal, meaning 2k and 2n has to be, this constants have to be different, but whatever, n can be anything. They just want to know k. So 2k must equal negative 28 over 15. Now we can solve for k. So I'm going to divide by 2, aka multiply by 1/2. Whoops, sorry. So then k equals negative 28 over 30, divide by 2. To simplify, negative 14 over 15 is the answer. And remember, on this test, you can have negative answers, right, in the free response. On the US version, you cannot. So if you have a negative on the free response in the US paper version, you know something's wrong. Okay, negative 14/15. I think that's good, right? Negative 14/15. Yeah, that works. Boom, done. 12, a gift shop buys souvenirs at a wholesale price of $7 each and resells them each at a retail price. That is 200. Okay, hold on. Buys on wholesale and resell. That's 290% of the wholesale price. So that means it would be 2.9 times 7. At the end of the season, any remaining souvenirs are marked at a discounted price that's 80% off the retail price. So whatever this is, 80% off, that is 20% left. So we multiply by 0.2. So we can plug this into the calculator. Oops. So we got 0.2 times 2.9 times 7. And hopefully I didn't make a mistake. Hold on. 0.2. So 2.9. So 200. That is 2. Sell the resources 290% of the wholesale price. So that times 7. And then 20% of that should be right. So 406 is the answer in dollars. Wait, what is the discounted price in dollars? Yeah, 4.06. Okay. Moving on. In the given equation, C is a constant. The equation has no real solutions. If C is greater than n, what is the least possible value of n? All right. So let's first do this. So if it has no real solutions, that means b squared minus 4ac is negative, right? And then b squared is, it's huge. It's negative 34 squared minus 4a is 1 and c is c. Must be less than 0. And now we just isolate c. 34 squared, I have no idea what that is. 34 squared is 1156. So we got 1156 minus 4c is less than 0. Subtract 1156. Negative 4c is less than negative 1156. Divide by 4 is 289. And we flip it. C is greater than 289. And that's cool because we had a C is greater than N. So obviously N is 289. See, one of the great things with these inequalities is just like set it up and isolate. Don't worry like, wait a minute, I don't know what this C has to be bigger. Like, I don't know that inequality. Just set up what you know to be true and isolate and look, you get a great outcome. Data set A consists of the heights of 75 buildings, has a mean of 32. And 75, mean of 32. Data set B consists of 50 and has a mean of 62. Data set C consists of both of these, A and B, what is the mean in meters of oh, got it. Okay, so this is actually a cool question. So the way that you can do this is if we know the totals, we can just add them together and divide by 125. And I can get the totals without the numbers as long as I know the mean, because I can take that mean 32 and I can multiply it by the amount of buildings there are. So it's 32 times 75. That's the sum for group A. And then for the second one, 62 times 50, right? Again, take the number times the mean. And now we have a total of 5,500 for all 125. And then to get the mean of that, we do that total divided by 125, and we get 44. What you don't want to do here is be like, oh, I just take the average of the averages. We can't do that because they're not equal amounts, so they're not weighted equally. So you have to do it the way I did it. Okay, 44. Next. The expression blah, 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 where b is a constant, can be written as this. All right, so factoring. Here we go. So let's just factor it right off the bat. And, oh, but they have a b. Wait. I think I can just figure this out, right? Because if it's 2x. No, because there's too many. Wait, does it say b is positive? It doesn't say b is positive. Oh, I see. Oh. And they say HK. HK and J are integers. Okay, hold on. Oh, I get it. I understand. Okay, so what they're basically, here's the dealio. I understand. So to get to this, okay, negative 45, right? We have, it's going to be 45 over something because look, here's the deal, right? K and J, it's 45 over K. Okay, I figured it out. I'll tell you why. So I know that K times J is equal to negative 45, right? Because at the end of this, we're foiling, and then K times J is going to give us that negative 45. And that means if K times J is 45, K is a factor of 45, so is J. So if they had 45 over J, that would also be an integer because it's a factor, so it divides evenly and becomes just like a straight up integer. So it's got to be this. I'm just double checking here because that would be 4, that'd be 1. And then that would be, I mean, I think the rest of it, yeah, you just can't, there's no other way really because, yeah, it has to be that. Hopefully that explanation makes sense. I got to keep going because I'm going to run out of time. Okay. In the given system of equations, A is a positive constant. System has exactly one distinct real solution. What is the value of A? All right. So it has one distinct real solution. That means I know, if, by the way, I can plug in negative 1.5 here. So negative 1.5 equals x squared plus 8x plus a, and then I can subtract or add 1.5 to both sides. X squared plus 8x plus a plus 1.5 equals 0. And then they're saying this system has only one real solution. That means that my discriminant here has to equal 0. Now I can do the discriminant b squared, which is 64 minus 4a, and then c is this entire constant. So you have to do a plus 1.5, and this has to equal 0. Okay, now we go to this point, and we're going to distribute that negative 4, and we get minus 4a minus 6 equals 0. 64 minus 6 is 58 minus 4a equals 0. And then we add 4a to both sides. 4a equals 58, and then we divide both sides by 4 like so. And we get, can I do in my head, 56 goes in, no wait, 60, 15, 14.5, but let's double check. That was just for fun. Let's make certain. 58. 14.5, boom. So that is the value of A. And should we check it? I don't know if we have time. If I checked it, I plugged it back in. It's x squared plus 8x plus 14.5. And we're trying to get this to equal 1.5, and then you subtract, and then it's 13. Wait, 13 plus 8x, x squared. Wait, is that just right? Hold on a second. B squared minus 4ac. That's not 0. Hold on a second. I must have made a mistake. Wait. Okay. 64. No, wrong one. Where was it? Yeah, here we go. X squared plus 8x plus a equals negative 1.5, positive 1.5, negative 4a minus 6. Hold on a second. Minus 6, that's 58 minus 4a equals 0. A, and then a is 14.5. Oh, wait, I can graph this. Hold on. Here, check this out. Y equals negative 1.5. This is the cool thing about Desmos. Let's just double check. Y equals x squared plus 8x plus, because we said it's, oh, look at this. It doesn't work. Oh my God, it's wrong. So then it is, how did I do this wrong? Wait, give me 1 second. I had b squared minus 4ac negative, and that has to equal 0. So we get negative 4a minus 6. And that's 58 divided by 4. That's wrong. Hold on. Something is not. It's 16. It's 16. Look. Wait, is that the x-axis? Oh, no. It was right. I was looking at the wrong thing. Yeah. Sorry. Look, it was right. It works. It gives us one solution. See? This is the line. I thought this was the line. This is the x-axis. Yeah. My bad. It does work. Okay. Woo. Wasted a lot of time there. Sorry. The dot plot represents 15 values in dataset A. Data B is created by adding 56 to each of the values in dataset A. So that would be 56 would be 78 and blah, blah, blah. Which of the following correctly compares medians and ranges? So the median data B is created by adding 56 to each of that. So obviously, right, B is going to have bigger median. So that would be ridiculous to have the same median. The median of dataset B is greater. So it's got to be C or D. And the range of dataset B is equal. The ranges are equal because if you're adding 56, it's still the difference of the biggest and the smallest. It's still going to be the same. So C is the answer. Okay. Whoops, I didn't skip something, did I? Nope. 18. All right. The rational function f is defined by equation, boom, where a and b are constants. The partial graph of this is shown. If f of x plus 4, if g of x, which equation would define g? Okay. So we're shifting it. So when you do x plus 4 like that, what you're doing is you're shifting it 4 to the left. Here, let me show you. Let me see if I can do this over here. You see, this is a, like, you can probably tell, right? This module is quite a bit more difficult than module 1. We're kind of blazing through module 1. So if we shift it, the plus 4 shifts it 4 to the left. So that point is now going to be here. Wait, let's see if we do bigger. That point's going to be there. This point is going to be here. You see what I mean? And then like out here. So it's kind of like this and like this. Okay. Anyways, which equation could define G? Oh, you know what we should do? Actually, the easiest thing here is, look, I got 2 nice points. I got negative 10, negative 3, and I've got negative 9, negative 6. So what I can really do is I can just plug and chug. Like, look, here. Yeah, because that is the graph. So I don't even care what A and B are, right? It doesn't matter. I can just plug and chug. So 6 over, so if I plug in negative 9, I'm clearly not getting negative 6. That's wrong. If I plug in negative 9, I get 6 over negative 5. That's wrong. Negative 9. This one works. Look, negative 9, we get 6 over negative 1. That's negative 6. Then plug in negative 10. Negative 10 plus 8 is negative 2. 6 over negative 2 is negative 3. It's got to be C. Let's see. This one doesn't make sense because the x plus 4 would cancel out and it'd be like just a line. And you can, look, you could graph these. You know, if I have time, I'll come back and I'll show you how you can verify. This is like so dope, actually, that we can use Desmos. It makes it so much easier. All right, next, I got to hustle. I know it looks like I have a lot of time, but I remember this one's tough. In the given equation, A and B are positive constants. The product of solutions, K, A, B, where K is constant. What is this value? K? Okay. Oh, this is the product, no, that's sum of solutions. Never mind. Product, I don't know the, Negative b over a is the sum of solutions. Oh, but there is a solution. It's like c over a or something. But I can't remember. Hold on. Negative b plus I can derive it. Look, negative b plus square root of blah, blah, blah over 2a. And then it's negative b minus square root of blah, blah, blah over 2a. And I can FOIL this. So I get 4a squared on the bottom. And then I get b squared. And then it's a difference of squares, right? That and that, those will cancel out. And then it's minus b squared minus 4ac. But this is all in parentheses. I can derive. So then I distribute the negative. And I get b squared minus b squared plus 4ac all over a squared. Yes, it worked. And then cross off the 4, cross off one of the a's. It is c over a. Yes. Okay, so you see how I derived it? But that's a one that I usually don't teach. But there you go. Digital SAT, I guess it could happen. So the product of the solutions is k, and the product of the solutions here is c over a, which is c is ab, a is 57. So the product of the solutions is equal to k a b. So obviously k is 1 over 57. Man, woo, that's a tough one. All right, graph of x squared plus x plus y squared plus y. What's the length of the square? Okay, we need to solve for the radius. Well, I need to get this into standard form. So we're going to complete the square. X squared plus x, take half of that term, which is half squared is 1/4. Same thing for this one. Y squared plus y plus 1/4 equals 199 over 2 plus 1/4 plus 1/4, because we have to add on both sides. 1/4 plus 1/4 is 1/2, so plus 1/2, and then we get 200 over 2, which is 100. And that's radius squared, right? And I could factor this and do all that and get the center, but it didn't ask for the center. So the radius is the square root of 100, which is 10. That's how you do it. Done. Next, 21. We got 2 questions left. Okay, come on. Let's go. Let's go. 2 identical rectangular prisms, each have a height of 90, so they're identical, blah, blah, blah. And a rectangular prism, in case you don't know, is like a little box, right? Let me draw it out like this. Okay, so they both have a height of 90 centimeters. The base, excuse me, the base of each is a square, and the surface area of the prism is k. Okay, cool, cool. If the prisms are glued together along a square base, so then I get it. Here, let me zoom out a little bit. If they're glued together by the square base, meaning we fit them together like this, kind of turn them on their sides. Wait, let's do it like this. Okay. If the prisms are glued together on a square base, the resulting prism has a surface area of blah, blah, blah. What is the side? Okay. So here's the deal, right? To get the surface area of each of these, we've got the area of the base. Let's call it A. Wait, and the surface area of each. Yeah, it's A times. No. Sorry. The way you do it is. Okay, hold on. Let's do it in side length. Let's see the side length. What is the side? Yeah, let's say it's by the side length. So let's say the side lengths are x, right? So to get the surface area, it's 2x squared because we take the base and the base, and then it's plus the height times the perimeter. 90 is the height times the perimeter, which is 4x. That gives the lateral surface area, so 4x. So that's one of them. So both of them, and then both of them would be 4x squared. 90 times 40 is 360, so plus 720x. So that's the surface area of these two. And then to get this, you notice we're gluing the bases together. So we're minusing those two bases, which are x squared, 2 of them. So we're minusing 2x squared because the ones we're gluing together, they're not counted anymore. So now we can say the surface area of this figure is 4x squared minus 2x squared is 2x squared plus 720x. And they're saying that equal. Oh, wait. Yeah. And then, oh, shoot, wait. 92. Oh, wait, I think I get how to do this, maybe? No. No, this doesn't work because now we got k in the mix. Hold on. Let me think about this for a second. So we need to somehow get a value for x, but right now we have k. And the thing is, k is the surface area, which means this equals k right here. This equals 2k. So it's really, another way to think about it is 2k minus 2x squared equals 92 over 47. I mean, that's another way to think about it, but that doesn't really do anything because we're still going to get x in terms of k, you see? So it becomes 92 over 47k. So it should be 2k. Oh, wait a minute. So then what's 2 minus 92 over, hold on. 92 over 47. Got it. So normally 2k is 94 over 47 because that's 2, right? This is what the area should be, but then you're minusing the area of the square base, 2 of them, whatever that is, 2x squared, and you're getting this, which means, I get it. So then, which means 2x squared must equal 2 over 47k, okay? Because it's 2/47 that you're shaving off apparently and getting the area. Okay, where can I go with this? Hold on. Where can I go with this? See, I knew this was hard. Wait, and then x squared, what is the side length? So then we divide by 2 and we get x squared equals k over 47. Man, we get a value. Okay, hold on. There's got to be another way to do this. So then 90. Oh, I haven't used the height. And then we know that k. Oh, maybe we can substitute for x. Hold on. I said that k was equal. I can. K was equal to 2x squared plus 360x. K is equal to 2x squared plus 360x. Okay, over 47. Now we got an equation. Here we go. Multiply both sides by 47. I think this is going to work. And then 47x squared equals 2x squared plus 360x. And then we're going to minus 47 on both sides. So we get 0 equals negative 45x squared plus 360x. Let's plug this into Desmos quickly. Oh my God, I'm running out of time. Okay, negative 45x squared plus 360x. And we need to know when this is going to equal 0. Obviously there and there. We got it. It's 8. Wait, did they have an answer of 8? Yes. Okay. Wow. That was a really tough one. Okay. 22. Here we go. Last one. 4 minutes. Oh my God. All right. So in the xy plane, parabola has vertex 9, negative 14, intersects x. Okay. Let's draw this out quick. It has a vertex at 9, negative 14, 9, negative 14. And hits the x-axis, intersects the x-axis at 2 points, so obviously it goes up, right? If the equation of the parabola is written in this form where a, b, and c are constants, which of the following could be the value of a plus b plus c? Okay, let me think. So we know it's going up, so a is positive. We know that it has 2 solutions, which means b squared minus 4ac is greater than 0, but that doesn't help. And then we know that we don't know about the y-intercept. We know that the vertex is negative b over 2a. So negative b over 2a equals 9. Does that help? And then negative b equals 18a. I don't know if that helps. So then I've got a plus and then I can say b, so b equals negative 18a. So I got a minus 18a, and then we've got plus c. Ooh, that doesn't help either. Hold on, let me think about this for a second. So a plus b plus c so that is the same as negative 17a plus c. Okay, let me think about this for a second. Y-intercept. Oh, I know. Better idea. Vertex form. Okay. y equals a times x minus 9 squared minus 14. Okay. And then we got a times x squared minus 18x plus 81 minus 14. Okay. And then we've got ax squared minus 18ax, sorry, plus 81a minus 14. So then so a is a, b is negative 18a. Oh my God. And then c is 81a minus 14. Okay. Let's see, negative 17 plus 81 is 64, right? So then we got 64a minus 14. Damn it, I still don't have a value. And I know a is positive. Wait a minute. Oh, but it could be a fraction. So if a is positive, this can't be negative 14. This can't be negative 12. So it's one of these two. It's negative 23 or negative 19. Okay. And it intersects it at 2 points. So it's one of these two. It's probably negative 23. Okay, I know a way to test this. Hold on. Watch this. So we've got here ax squared minus 18ax plus 81a minus 14. Hold on. And then we're going to add a slider for a. And then when a, so it's saying that which of the following could be the value. So they want it to be negative 23, which would be, wait, what am I saying? I went the wrong way. It's negative 12. Sorry. A can't be 0. It's negative 12. Ooh, I caught that. But anyways, so to be negative 12, that's 2, and that's 1 over 32. So A is equal to 1 over 32, and it works. Let's see. Is that correct? Come on, baby. Yowzers. That was tough. Okay, let's see how I did. Did I get anything wrong? Excellent. Okay, hold on. Why is this doing it? Here, let me do it. Let me get in here. So let me move it down, sign in, and then I'll bring it back up. I just don't want to put my info all out there. One sec. Boom. Oh, wait. Can I do it? Okay, there we go. Okay, I did get a perfect score, but I know you can still get stuff wrong when you do that. Oh, wait, what? Oh, those are all old. So this is the one, right? August 23rd? Yeah, August 23rd. So let's see. How do I go to math? Okay, correct. Oh, come on. Yeah, I got them all right. Wait, didn't I? Or did I get one wrong? Okay, yeah, I got them all correct. Sweet. That's much better than, that was great. So anyways, yeah, but you see, Module 2 is no joke. It's pretty tough, those last couple problems. Like, those problems are tougher than on the paper US version, in my opinion. The answer has to be, can't be less than negative 40. Yeah, exactly. Dude, I caught, see, but I did it in reverse. Did you see that? I messed it up. I'm like, less than negative 14. Negative 12 was out. I did it backwards. So, but I caught it. Yeah. Woo. Tough. Hey. Learning science is fun. What a legend. If you guys want science help, go to his channel. That guy's killing it. He's got like over 100K subs. He's the man if you want to do cool science stuff. He's the new science educator of the century in my humble opinion. All right, guys, I hope this was helpful, all you international students. Now, first of all, if you haven't done so yet, please click that like button and make sure to subscribe. But I want to tell you guys about tomorrow because tomorrow is very important. Tomorrow, we're doing a live stream starting at 9 a.m. And it's going to be for digital and the regular version. And I really want to make sure you guys join because we're going to cover everything. We're going to take questions. We're going to get you guys ready and comfortable and confident for the test day on Saturday. So that's that. That's the big one. That's the one that usually we have a few hundred people joined. So make sure to check that out. Again, make sure to click subscribe if you haven't done so yet. Click that like button. Thank you guys so much, and I wish you the best of luck on your SAT math journey. See you in the next video.